Let's have a look at some reactivity tests and extraction methods. So potassium, sodium and lithium all react very quickly with cold water to produce a metal hydroxide and hydrogen gas. So potassium is the most reactive of those three metals, and it reacts very quickly with cold water. Now the hydrogen that's produced in the reaction will ignite instantly, and the metal will also be set alight. And it will basically create sparks, and the metal will actually burn itself, and it will burn with a lilac flame, which is like a pinky purple colour. Now sodium will react with cold water by fizzing rapidly and melting to form a ball that moves around the water's surface. And lithium will also fizz steadily and float, becoming smaller gradually until it eventually disappears. So the trend is, the further down you go down that group, the periodic table that has those metals in, the more reactive the metal gets. So which metal burns with a lilac flame when it comes in contact with cold water? Well, remember, that is potassium. The metal sets alight because of the hydrogen that's given off and the heat that's given off during their reaction, and it burns with a lilac flame. Now, reactions of reactive metals with water. So a metal will react with water to form what we call a metal hydroxide and hydrogen gas. So most metals react with dilute acids to produce a salt and hydrogen gas. So metals that don't react with dilute acids are copper, silver, gold, and platinum. Now all the other metals will react with dilute acids. So some of the metals that do react are magnesium, aluminium, zinc, iron, lead, but iron and lead will react more slowly than the others. So what is produced when a metal reacts with dilute acid? Well, if you remember from earlier, the first thing that's produced is hydrogen, and a salt is also produced. Just to run through some of those reactions again. So the metals reaction with water produces metal hydroxide and hydrogen, and the metals reaction with dilute acid produces a salt and hydrogen. Now, when we're thinking about extraction of metals, most metals are found as compounds because the metal has reacted with other elements in the past. So this is when we're thinking about getting them out of the ground. Because of this, the metal has to be extracted from the ore where the metal compound is found. Now, ore is just the word that we use for rock, basically, it's got metal in it. So metals are less reactive. Metals that are less reactive than carbon can be extracted from their oxides by reducing it with carbon. So if you react the metal that's less reactive to carbon with carbon, then it will be able to be extracted. And that's used because carbon is cheap and there's lots of it around. So the reduction of the metal oxide makes the metal oxide actually lose oxygen from the pure metal. And the reduction with carbon normally involves heating the metal oxide in the presence of carbon, which is used to form coal. Now, to recap that, in a reduction reaction with carbon, a metal oxide loses oxygen to form pure metal. And what type of reaction is used when extracting metals with carbon? Well, that is a reduction reaction. The metal is reduced because the oxygen is being taken away from it. Now, what is produced when reactive metals react with cold water? Well, the first thing you get is a metal hydroxide, and the second thing you get is hydrogen gas. And metals that can't react with dilute acids, well, they're the least reactive metals, so silver, gold, platinum, and copper. Now, which metals react with dilute acids but not cold water? So the first one will be magnesium, aluminium, zinc, iron, and lead. Remember, you've got those other three, potassium, sodium, and lithium, that do react with cold water. Metals that are less reactive than carbon can be extracted using a reduction reaction with carbon. And some of those metals that can't react with dilute acids again. So we've got gold, platinum, copper, and silver.